Okay, folks, just wanted to throw together one more video for section 2-4, this idea of solving equations with variables on both sides, and just a couple special cases that happen when we do this, as well as a little bit of an application problem that we can kind of challenge ourselves with here. So I just want to take these two problems, and they're very similar in nature, but the result is quite different from each other. So let's start just by looking through them and working our way through them and talking about the steps we take to solve an equation. So the one on the left we'll start with. As we see, we go through the same process that we've gone through in the past of solving an equation. We first look to see if there's distributive property, and if you notice, we have distributive property right there. So we need to first distribute that 3 in. When we do that, you do 3 times 2b, we'll get 6b, and then 3 times -1 is -3. And then we just write down the rest of the problem as it goes. So there's our first step in solving this. We said after you distribute, look to combine like terms, and we have like terms again. We have these guys over here, those are like terms. So as I continue to write that down, it's 6b, -3 and -7 give me -10. And that's equal to 6b minus 10. Now, if you notice, both sides of the equation are exactly the same at this point. But let's continue on and see what happens when we continue moving through our steps. So after combining like terms, we look for fractions. And there aren't any fractions in this problem, so we don't have to worry about those. But we want to move variables. And this is where section 4 was different from everything else we've done, is we have variables on both sides of the equation. So we need to choose a side to move. Now, it doesn't matter in the grand scheme of things which side you choose to move your variables to. Sometimes you end up with a negative, and that might be more difficult for you to work with, but it really doesn't matter as you go and do this. So let's choose. I'm going to move stuff to the left side, so we're going to go this way. So in order to do that, I'm going to subtract 6b from both sides. And I get 0 over there, and over here, if we notice, I get 6b minus 6b. Well, that's 0 as well. And what I'm left with is a problem that looks like -10 equals -10. Now, we've seen this happen before in chapter 1 when we talked about solving a basic equation. It's coming back and seeing this again. If you'll notice what happened, we had variables canceled completely. Hold that one on. My eraser here. Our variables canceled completely. And we are left with a statement, if we look, that is a true statement. And if you remember, when we had that before, we had the idea of, well, if it's a true statement, then no matter what happens, no matter what value I put into that problem, I'm going to get a result that's true no matter what. So variables canceled, we have a true statement. What we call this is infinite solutions. So any value will work for this problem. Now let's compare that with this problem over here, which is very similar. Again, we have distribution, so we distribute the 3 in. So we have 5x plus 5 will equal 15x minus 12. Oops, let me back up a little bit. Will equal 15x minus 12 and then minus 10x. So once again, we need to combine our like terms, and if you look, those are 15x and 10x. And we have 5x plus 5 will equal, we have 5x minus 12. Let's continue on, as I know our next step was to get variables on one side. So we're going to subtract 5x from both sides. And like before in the previous question, both of our variables on both sides cancel completely. But if we look at the result, I have 5 equals -12. So in this case, I have variables canceling completely, yep. But now I have a false statement. 5 is not equal to -12. So instead of infinite solutions, in this case we call them, there are no solutions. Okay. So we look at those, we call them identities. There's the idea that variables cancel out, or they get added and subtracted into 0. So there is no variable left anymore, and you're left with a numerical statement. It's either going to be true or it's going to be false. In this case, 1 is true, it's infinite solutions, and 1 is false, there are no solutions. So that's just some special cases as we go. So keep an eye out for those as you are working through. Don't be freaked out if your variables do cancel out. It just means it's a special case. All right. So then the other one I want to look at is this idea of an application. So let's move on to this next video down here. This is an application of equations. So find the value of x. So there's some directions. So the figures have the same area. And remember, we have the same. Okay? Same means equal. So I know the area. So if I have the area of the square, it needs to be equal to the area of the rectangle. That's what we're saying. That two pieces are equal. So let's go ahead and find the area. Well, no matter what, this is area equals length times width, and this is also area equals length times width. For the first shape, it's pretty easy. We have an area of x by 10, so this area will be 10 for your length, x for your width. So the area is going to be 10x centimeters. Okay? That's the area of the width. Now, on the right, we have a little work to do first. We have the width here, that's nice, the 6 centimeters, but on the bottom, it's 3 centimeters from here to here, and then x from here to here. So we have to put those together. So really, the whole thing together is 3 plus x for the whole width combined. So we need to factor that into our area over here. So area is going to be length times width. Length is 6. Your width is now 3 plus x. So if we distribute that 6 ends, your area here is going to be 18 plus 6x centimeters. Okay, well, we found the individual areas. Now we need to go back and figure out the value of x. Well, again, we go back to this idea that they have the same area. So if I know that they have the same area, I can say that their areas are equal. So I can say that 10x is equal to 18 plus 6x. That gives me a pretty simple equation to solve. Now, here's where we can work harder, not smarter than we need to. There's no fractions to deal with. There's no distributive property to deal with. We simply need to move things around. So we have the option of what side to move our variables to, but again, if we look, we have 18 over here. That's the only constant that's on the right-hand side already. So we want to move your 6x over to the left side to keep it away from that. So it's a positive 6, so we're going to subtract 6 over here and subtract 6x over here. That will give me 4x equals 18. Then we just go ahead and divide by 4. Pretty straightforward. X is going to be, if we reduce that, 9 over 2. And that's our idea. So about 4.5. But those are just 3 extra examples, something a little more, one application and a couple special cases that happen. Put those in your notes. Make sure you have them ready because you're going to see stuff like that show up throughout the chapter as we move forward with this idea of solving equations. Have a great day, folks.